Yes, welcome you all for another presentation on transistor CE configuration. Let us see CE configuration, that is common emitter configuration. Common emitter configuration. Common emitter configuration, right? How a transistor looks like in CE configuration. I will show you the diagram for this basically. As I already told you in our previous presentations, remember that basically we have three types of configuration because as we have three terminals of the transistor, namely it is it is called emitter, this is called collector, and this is called base, right? As we have three terminals, therefore the transistor can be operated into three configurations. Okay, if you put emitter as common with respect to remaining two, that is called as common emitter configuration. Otherwise, similarly, if you put the base terminal as a common with respect to remaining two terminals, then it is called common base. And if you put collector as common with respect to remaining two, then it is called as common collector configuration, right? So here, so in common emitter configuration, the emitter terminal is kept common with respect to remaining two terminal. And remember that as I already told you that the first foremost is CB configuration, next is the CE configuration, and third is the CC configuration. Clear? One is the CB configuration, right? CB configuration, and next is the CE configuration. Clear? And the third one is CC configuration. These are the three configurations in which the transistor can be operated. Remember that. So the transistor can be operated as an amplifier, especially in these two categories only, CB configuration as well as CE configurations only. These two are configurations widely uh, used for amplification purpose. And again, in these two, the CE is predominantly very important. CE is very important configurations, right? And CC will be used for different applications, not an amplifier. CC configuration will be used for other applications. Okay, this will not be used for amplification purpose. No. So CC configuration will be used for other purpose, right? And whereas especially it is used for some impedance matching purpose. Okay, impedance especially, that is the its main advantage or application, impedance matching. Why? Because its impedance, input impedance is very high. In common collector configuration, the input impedance RI is very high actually. The RI input impedance is very high. Therefore this can be used as an impedance matching circuit, right? Okay, that we will see little bit later. Now remember that again in these two configurations, CB configuration as well as CC configuration, the output, right? In these two configurations, in CB and then CE configurations, the output, right, will be taken as, the output will be taken at at collector terminal only, means collector. So collector terminal is the output. That is the, that's what I want to convey is, right? In these two configurations, means in CB configuration as well as CE configuration, the output is always collector only, right? Collector only. Therefore now coming to the CE configuration, once if you put the emitter terminal as common with respect to remaining two, definitely if you put emitter as a common, then definitely which is input terminal and what is the output terminal, I already told you now. So the output is at collector, therefore always remember that the collector is output terminal, then obviously our base is input terminal, because emitter is common. Therefore, base is always input and collector is output, right? So likewise, you need to remember in order to, I mean, in order to have without any confusion, right? Otherwise, if you do not, I mean, remember like that, then there is a chance of getting confusion. Now I will draw a simple circuit of CE amplifier. So this is the emitter terminal actually. This is what your emitter, and this is what your collector terminal, and this is what your base terminal, right? This is the base terminal. And as I already told you that between these two, this is base to emitter. So this is definitely will be put at 0 level common. This will be grounded actually, right? So in between, actually this is the basic circuit which I am giving you, or otherwise you can draw any circuit, no problem. Afterwards I will explain you a little bit more. This is the basic circuit which I am explaining you that, right? So in general actually, so between base to emitter, this is VBE is the voltage will be there. This much of voltage will be there between base to emitter and again this is the flow of emitter current, it is going out actually. Then obviously so the flow of IB is like this, that is base current, and this is the collector current, the flow of collector current is like this. And between this emitter and then base, we can join this line with this ground line, no problem. And between these two, because it is N, remember that this is N, this is P, this is N, it is a NPN transistor. Therefore your input terminal is base, and then here the base terminal is P type material actually. So therefore I already told you in the first lecture of this starting of this class. Okay, so the input junction must be forward biased. For an amplifier circuit, the input must be forward biased, whereas the output junction must be reverse biased. Therefore, if it is in forward biased, then you should connect, the connection will be like this, right? Because this is plus and then this is minus, and normally you can call it as, no problem, you can write VBE, base to emitter voltage. So between base to emitter, because that P is the positive P type material, therefore it is a positive, majority carriers are holes only, therefore it is a positive one, positively charged particle. Therefore this, for this positive you need to connect the positive terminal of the battery, right? Then it is called as the forward biased, the input junction is forward biased, right? Between base to emitter there is the input junction, no? So this junction will be forward biased actually. Similarly, so how the output junction, output must be reverse biased. Again it is NPN, N is nothing but N is N type material, I mean it is a majority or electrons, therefore it is a negatively charged. So for this negatively charged you must give the positive. So in reverse bias we will connect the reverse actually. So we will connect for this negatively charged particle, means electron negative, therefore for this negative if you connect the positive, then it can be called as reverse biased. Then what is this actually? Obviously it is VCE, nothing but your collector to emitter voltage, nothing but this is the voltage between collector to emitter. This is the basic circuit. Because of this VCE, your current, the current flows like this, the direction of the current is like this only, it goes like that, and this flows like this actually. So the current direction is like this, right? This will be like this, as I have shown. This is the flow of current actually, collector current. This is the IB, base current. Base current is like this. This is the base current. Obviously the emitter current is like this only, right? So therefore what is the input current here? IB is your input current. What is your collector current? Collector current. This is the your output current, right? So here one important point which I want to uh, explain you, which I want to tell you is that, so with this connection, so means that what actually this input junction is now forward biased. This is the base to emitter junction. This is definitely, it is a forward biased, right? Whereas between collector to emitter, this is definitely it is a reverse bias. Therefore, what you can say, so now it can be acts as an amplifier circuit. This is called a common emitter amplifier, right? This is called common emitter amplifier. Clear? Now remember that normally in the amplification what we will do, we will apply some input voltage, no? Some input voltage we will give normally. Some sinusoidal signal you will give as input, right? Peak to peak voltage, some amplitude will be there, peak to peak voltage, some small signal will be given as an input signal at the input junction, and obviously you will see the output at collector, means that here you will see the output normally. Is it not? Is it not? So your output will be at collector terminal, you have to see its output. Now there is a one important point basically. See, as emitter is grounded here, okay, you can represent like this also. All this, it's okay. You can show like this. It indicates it is a reference line or zero potential. This particular line means this particular terminal is connected to this line. It is a ground line kept at zero potential, right? Now the important point is that see that the flow of input current and the flow of output current. Clearly observe that. What is the flow of the current actually? It is going forward direction. The arrow mark is going to forward direction, right? It is a forward direction. Whereas if you see the collector current IC is coming reverse direction actually. So the flow of current IC is coming in this reverse direction, right? This is forward direction, this is reverse direction. Thereby what you mean to say is that here the phase shift between input current and then output current, there is a 180-degree phase shift will be there. 180-degree phase shift will be there in CE amplifier. What is the meaning of it? It means that, so if the input is like this, and definitely your output, if you see the output, your output will be something like this. So your output will be like this. It starts like this actually. Your waveform will be like this. Always remember this point. It goes like that. So okay, the amplitude of the output signal must be very high comparatively the input signal. Not only that, there is a phase shift actually between input and an output. This is your input side, this is your input signal, and this is what your output. This is what your output. Okay, so see, so the waveform, it is 0 to positive cycle and then negative cycle. Here it starts 0, negative to positive. So this indicates there is a phase shift of 180 degrees between these two, right? Therefore in CE amplifier you will get 180-degree phase shift because of this flow of the current direction. That is very important, right? So if you compare this particular circuit with our previous configuration, I think CB configuration we have seen in the previous slide, previous presentation. Okay, then in that case there is no phase shift because both the currents are in the same direction. Both the currents are input current as well as output current. Both are in the same direction. Therefore, there is no phase shift actually in CB configuration. Okay, but this is even in CC also there will not be any phase shift. In CE configuration only you will get the 180-degree phase shift actually, right? That is very important point to note actually, right? So this is the input signal. However, the purpose is same because the small signal will be converted into large signal as well as the weak signal will be converted into strong signal. That is the definition of an amplifier, and that will happen really in this both the CB configuration as well as the CE configuration, right? And other than that, this is the very important point to note down. Even while doing your experiments in your laboratories, you must see that your output must be like this. 180-degree phase shift must be there. Otherwise, suppose if you are not getting this particular, maybe somewhere you have done some mistake actually. Your connectivity is something wrong. So you have not connected the transistor in CE configuration. Somewhere some mistake will be happened in the circuit. Okay, if you are connected the C configuration in proper way, then definitely you should get 180 phase shift degree. That is a simple, cross checking point actually. Okay, so if you get this type of output, 180 degree phase shift in your CRO, then perfectly your connection is very nice, very good. Then no doubt at all. So you are given a very nice connection, very proper connection, and it is now it will works as an amplifier. Clear? So this is what the basic thing that to remember actually. Otherwise, remaining process same what I already explained in the CB configuration, right? So here the input current is IB, base current is the input current, and base to emitter voltage. This is what your input voltage actually. The voltage between base to emitter is the input voltage, IB is the input current, right? Similarly, if you see at the output side, so the output current IC is the output current and the voltage VCE. So sometimes it can be VCE, you can show like this also, VCE. This is what your output voltage, right? So now individually we can plot the graphs for input characteristics as well as the output characteristics also. Okay, input characteristic and then output characteristics we can plot. So if you see the input characteristic, what is the input characteristic, that I will little bit explain you about these characteristics for both CB as well as CC in the next subsequent presentation, but right now I will explain you very briefly. Input characteristic is nothing but it is a graph. It is a graph plotted between the input voltage and input current, right? So the input voltage is nothing but VBE, that is taken on the x-axis, and the input current IB will be taken on the y-axis. So by taking voltage on x-axis, by taking the current on the y-axis, if you plot the graph actually between these two, okay, then you will draw the graph actually. You will draw the graph. So that is what the input characteristics. And from input characteristics, you can find out the input impedance actually. The input impedance Ri is the input impedance. From Ohm's law, what is Ohm's law? V is equal to I into R. And from this, I is equal to V by R. What is V here? This V is nothing but the input voltage. What is the, okay. So it is R, so input impedance V by I. R is equal to V by I. R is equal to V by I. So V is nothing but input voltage, I is nothing but input current, right? So likewise, so if you draw the graph between input current and input voltage, that is called input characteristics, as well as similarly the output characteristics are nothing but it is the graph plotted between the output current to the output voltage, that is IC versus VCE, right? Same way. So your VCE can be taken on the x-axis and your IC will be taken on the y-axis. Then we have to plot the graph. That I will show you how the graph looks like, right? So that is one important thing. And here one important point to note down is that while plotting or while estimating the values of IB and VBE, while doing our experiments to obtain the values of IB and VBE, remember that the output voltage VCE must be kept at constant. Remember that. So in order to take the values of IB and then VBE, we must put the VCE as constant. Okay, output voltage must be kept at constant, right? So for example, VCE you can put at 0 volts initially. VCE can be put for what? For input characteristics. So for calculating or for plotting the input characteristics, we need to, plotting is nothing but plotting the graph for what? For different values of VBE, for different values of IB. So for taking different values, maybe you may take some 10 readings actually, 10 different values of VBE, and for corresponding VBE you need to find out the different values of IB. So in this case we have to put VCE as constant. It means that in the step 1, let us say for the step 1, let us put VCE at 0 volts. Now you can vary the VBE slowly in steps of 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7 like that in terms of voltages. Means 0.1 voltage, 0.2, 0.3 volt, 0.4 volt, 0.5 volt. For each different voltages, what is the corresponding current of IB? Some milliamps. Definitely it must be in the order of milliamps only. It is In the input junction, normally you will get the characteristics as just like your normal PN diode, right? If you see the PN diode, in PN diode also, we will plot the graph input, forward bias characteristics as well as the reverse bias characteristics is there. So in the reverse bias characteristics, how the diode will, how that VI characteristics looks like, exactly the same. Whatever you will see in PN diodes forward bias characteristic, the same will be looks like here also for this input characteristics of a transistor, right? Therefore, understood. So by keeping VCE at constant voltage and by varying the VBE from different values, for all these different values you must consider, you must note down the values of IB. For these different values you must plot the graph. That is step 1. Now coming to the step 2. Now you little bit increase VCE to some 1 volt. The second step is let us VCE change it to the 1 volt. And again the same. Start from VBE again from 0, 0.1, 0.2, 0.3, 0.4, 0.5 like and so on and so forth. And for different values of this VBE, and you must take the values of IB for your multimeter and plot the graph. Similarly, now VC is equal to some 2 volts. So likewise, at least some 6 to 7 or some 10 readings will be taken. This is for laboratory purpose I am explaining you, right? Means that in each step, the output voltage must be kept at one particular constant value, and by varying the input voltage and corresponding this variation of this voltage, you must note down the corresponding values of IB input current, then plot the graph. Then you will get the input characteristics. It is something, it will be like that actually. This I will explain you very clearly in the subsequent presentation. This will like this. Your graph will be like this. It will goes like this. This is what your voltage, this is what your current, means VBE, this is what your IB input current, this is for different values of VCE. So VC for constant value like that. That is for input characteristics. And similarly, while plotting, while take the values of the output characteristics. Clear? So what are the output characteristics? It is these are the values of IC and VCE. Then remember that input current must be put at constant. Okay? While taking the values of the output current and output voltage, we must keep the input current at constant. Clear? Is it not? Means that what? IB is equal to some 0 milliamps initially. IB will be put at 0 milliamps, and correspondingly by varying the VCE in steps of just like what we have done at input side. In the same way, you can vary the values of VCE, and for different values of VCE, take the different values of IC. And that is step 1. And again in the step 2, now IB is equal to some 1 milliamps. And second, third, 2 milliamps, 3 milliamps, 4 milliamps. For different values of IB, for each and every particular values of IBs, you just vary the output voltage VCE. For all the different values of VCE, take the IC value and plot the graph. You will get the characteristics. That I will explain you later in a subsequent presentation. So these are the very important points. So first thing is, remember that the common emitter configuration offers 180-degree phase shift between input current and then output current, right? And your output current must be like this, the output voltage must be like this. And similarly, in order to draw the input characteristics, obviously the output voltage must be kept at constant, and for measuring or for calculating the values of the output characteristics, input current must be put at constant. This parameter is also valid for the CV configurations also. In CV configurations also, for plotting the input characteristics, the output voltage must be put at constant, and similarly, for plotting the output characteristics, the input current will be put at constant. This is the very important things to note down. This is the brief information about this CE configuration, right? So therefore here the output current is IC, input current is IB. If you take the ratio IC by IB, this is called as actually beta. This ratio is called as beta in common emitter configuration. Beta is called as current gain. It is the ratio of current, no? Output current. IC is called as output current. IB is called as input current. Ratio of output current by input current is called as the current gain. Current gain, and is denoted by the letter beta. And normally this beta value is normally it starts from 50 to 200 normally. in general. Even more than these values are also applicable are available in the market, but in general we will consider 50 to 200 the current gain. So more than 200 value of current gain transistor also available, right? So in general, these are the value current gain. So this is the current gain in general. And similarly, what is the voltage gain? It is the ratio of output voltage by to the input voltage, that is VCE by VBE. And similarly, the input impedance. Input impedance is the ratio of our input voltage by input current, VBE by IB. Similarly, output impedance, VC by IC, right? So likewise, we have to see the parameters, and these are what the brief explanation about, right? I hope that I will finish off this presentation here, and will continue in the subsequent presentation by covering the remaining common collector configuration. Also we will see in the next presentation, and afterwards I will explain you the input output characteristics of both CB configuration as well as CC configuration, and afterwards we will see the biasing concept of transistors, how transistor can be biased, what is the meaning of bias, why biasing is required, and what are the various parameters that depends on the temperature, and what parameters we have to consider, right? So likewise we have to see some parameters, and because I am focusing on theory part now, and after completion of this theory, obviously we can go a little bit depth in solving the previous gate questions as well as UPSC IAS questions actually, right? I hope it is quite enough for today's presentation, and I will finish off here, and right, we'll meet in the next presentation, and don't forget to give your valuable feedbacks and suggestions, and request you all to share this information with all your friends and your friend circle relatives, so that most of the students must be benefited from these presentations. Okay, so this is what my desire and ambition of giving these lectures, and with this we'll close today's presentation. Have a good day.